Okay, so this is the third 15-minute video. I can only shoot videos in increments of 15 minutes, so sorry about that. So I was on problem number 4, and I had begun to set it up for you. I was showing you that the degrees cancel and you have radians on the top. So when you're multiplying, don't forget that 105 is the same thing as 105 over 1. So you're going to go top times top as you would multiply any two fractions, top times top. And then the 180 is the divisor. What you're going to probably want to do is get your calculator possibly to help you simplify the fraction if you don't feel like messing with that, which means you're just getting it to simplify this coefficient in front of pi, the 105 over 180. So if you don't already know how to simplify with your calculator, you just go put in the fraction, not including the pi. And instead of hitting enter to get it to reduce, hit the math key, which is in this first column, third key down, hit math. You'll see that it's on fractions. That means it's about to reduce a fraction. So just hit enter twice. Enter, enter. And it'll tell you that 105 over 180 in its most reduced form is 7 over 12. Okay, so your final answer here would be 7 over 12. With the pi hanging off to the side. Do not dip the pi down into the bottom. You can either leave it at the top or write it slightly off to the side. When you bring it down into the bottom, that answer becomes something else, not what this is. Okay, so that's number 4. Moving on to the next problem, which is number 5. Same thing, only this one just has a negative. So it's negative 210. Put your converter ratio here. You know what to put on the top based on what you're going into. Radians is the pi number, the decimal number. 180 is the degree number. So now again, just like in the last problem, number 4, the degrees cancel. You have 210 over 180, and you can either put that in your calculator to reduce it, or you can reduce it yourself. The zeros would cancel. You'd be looking to reduce 21 over 18. 7 is the number that goes into this as well as this. 7 goes into the top 3 times. And, sorry. Oh, not 3. 3 is what I should be reducing by. Excuse me. 3 goes into the top 7 times, and 3 goes into the bottom 6 times. Don't forget the negative, and don't forget the pi. So that would be your answer there. Okay, if you want to, you can put in your calculator 210 over 180. Just don't forget to put your negative and your pi symbols. Okay, then we go into 6 and 7, which are both the same type of problem. One has a negative in front of it and the other one doesn't. So when you're doing this kind of problem, same thing. Start with what you're being given. Put your conversion ratio, your fraction, right next to it. What you're being asked to convert into always goes on top. So you know whether to put degrees at the top or radians at the top. And what it's equivalent to goes in the other position. These two things are equal, equivalent to each other. In this case, instead of degrees canceling, pi's cancel. And then you're going to put the rest of it in your calculator. Top times top divided by 4. Okay, so that'd be 3 times 180 divided by 4. And that's 135. Okay, then for the next answer, problem number 7, same thing. You have 5 pi over 6. Put your conversion fraction here. I'm converting into degrees, therefore degrees go on the top. That's what I've been emphasizing in these last 4 problems. Unit you're going into goes on the top. Other one goes on the bottom. Pi's cancel. And then you put this in your calculator, 5 times 180 divided by 6. Okay, so that would be 150. And if there's a negative involved, don't forget to put that. Okay, that's your answer there. Okay, then in number 8, we can also do that one. We have 4.83. Now, this is already in radians. As I said, radians is just a word that means decimal. The reason you don't see a pi symbol is because they only use pi when the amount of radians is exactly 3.14. Of course, that number runs on and on. But this one is a different type of radian number, so you don't see the pi symbol. But you're still going to go about the problem the same way. If you're going into degrees, as I've said in the last 4 examples, you put degrees at the top, pi down here. Only this one, notice that now all of a sudden in this problem, as opposed to the last 4 I've done, it actually now says round. Therefore, every single number is going to be pressed into the calculator. Everything goes into the calculator. This is 4.83 over 1, so it's top times top, and then there's only one divisor, dividing by pi. So that would be 4.83 times 180 divided by, and now call up the pi symbol. Here is your pi symbol right here underneath the clear button. It's in orange, therefore you have to press the orange key first to call it up. So your answer is 276. They ask you to round to 2 decimal places, so 276.74. Okay, then number 9. Now, I could have you do these by hand. I could introduce this to you, and I will talk about it, that on your theorem sheet, this is the next thing on the theorem sheet, where it talks about degrees, minutes, little single hatch mark like that means a minute, and seconds. A double hatch mark means seconds. 6 minutes are portions of a degree. In fact, it takes 60 whole minutes to make up a degree. So when you don't have a full degree, you might have a portion of that degree, like 50 minutes or 46 minutes leading up to a degree, but not actually making it to the next degree. And sometimes they want you to convert every little portion of the number, including the minutes and the seconds. I'm going to let you do when it's all that type of conversion, I'm going to let you do that in the calculator. Likewise, seconds are certain portions of a minute. We all know that it takes 60 seconds to make a minute. And let's say that you have 27 minutes and then another 32 seconds. You never made it to 28 minutes, but you have a certain portion leading up to the next minute. So this is just a smaller portion of this. These are smaller portions leading up to that. But you can take something and convert it completely into degrees. Like, for instance, in number 8, or not number 8, number 9, it says convert the angle to a decimal in degrees, to a complete decimal. So in other words, they don't want you having 3 different symbols here, degrees, minutes, and seconds. They want you to take all of this, and you could do this by hand, but you can do this by calculator. It doesn't warrant our time. It would take too much time just to do that. And we're going to actually be doing word problems where this is required, so we can at least do that part in the calculator. So all you have to do is know what the key is that'll allow you to paste these symbols on the different portions of your number, and then we're going to convert it to a pure decimal. Okay, so let's see. We have 39. The key that allows you to get the degree and the minute symbol is second, and then angle. Angle is this key right here that says apps on the key. So right there, press enter to grab that degree symbol, then go and grab type in the next number, which is 47. Now you're going to paste a minute symbol on it. So go back to that same menu, second, angle, and go grab the minute symbol. Go down to minutes, press enter, and you've pasted the minute symbol. That menu did not have seconds on it. So type in 32, and then where you can find seconds is down here. If you go right here where the plus sign is, notice that there's a little double hatch mark here for seconds, and it's in green. That means you have to press this green alpha key first, and then get down here and press this plus sign where the seconds symbol is. And that'll paste seconds onto that last number. Now you have the number as they've given it to you, and you can just go right into pressing enter, and it'll convert it completely into degrees. What you see here, the 0.792222, is the portion, all the portion that you got from the minutes combined with the seconds, leading up to 40 degrees, but never quite making it there. You're at 39.792, round off to whatever they've asked you to. In this particular problem, number 9, they've asked you to round to 2 decimal places. So this will be 39.79. Okay, and number 10. You can also convert from something that's already like this and get it back over here using that same menu where we just were able to convert this into total degrees. So we're going to press this in. Now, when you're doing these two types of problems, it doesn't actually matter what mode you're in. We're going to be talking quite a bit about mode. That's this key right here. And in fact, in a lot of problems, it will matter, but here it doesn't. So I'm going to clear that out. We're trying to convert 60.41 degrees into this type of number, as the directions say. Convert the angle to degrees, minutes, and seconds form. So all you have to do, and if you put no symbol on it whatsoever, you don't actually have to go and paste it. If there's only one symbol, you don't have to attach it to the number. So 60.41, that's right there. Now go to second angle where we found all those symbols. And if you go down to option number 4, you're going to have to press enter twice. It'll take it into degrees, minutes, and seconds. That's what DMS is. So go once, enter again twice. All I did was go down to option 4 and I pressed enter twice. And you can write that in your notes. That's why it's good for you to have the outline in front of you, because instead of writing the whole problem, you can just write the little comments of calculator commands and certain things that you think you're going to forget. So it was 60 degrees, 24 minutes, had the calculator, and 36 seconds. And my math lab will offer the symbols to you without you putting them there. Okay, last two problems are numbers 11 and 12. I might get cut off in the middle of these and have to go to the next video, but we'll see what happens. So we need another formula. So moving to the next page of the theorem page, this will take care of numbers 11 and 12. There is the theorem right there. For arc length. I drew a picture of it instead of just giving you the formula. This is a formula that was covered in geometry and it is used again in trigonometry. Here's a picture of a circle. These two arms are called radii. They make an angle between them right at the center of the circle. But when they dig into the circle, they cut out, or the word is called subtend. They cut out an arc. And in order to find the distance from here to here, which is called arc length, what you see right here, you need this formula. So to find a distance that is not linear, not a straight path, but rather a portion of a circle, you're going to need to multiply radius times the angle at the center of the circle, which is right in here. That's your theta right in there. The theta needs to be in radians, so it needs to be a decimal or a pi type number in order for you to use it in this formula. In fact, almost all the formulas you use are going to require theta to be in radian form, not degree form. So that if they do give it to you in degree form, you're going to have to convert it before plugging it in to this formula. Okay, so in the next problem that we're going to do 11 and 12, and I will just reserve that for the next 15-minute video.